Ladies and gentlemen, what's up? What's up? What's up? How we doing? How we doing? My name is Fahim. I am a third year computer science student now. Like I just finished my second year. I'll be soon in my third year. And today we are doing an important work. We will be doing what we'll be doing, bro. Let me explain. So I got a research internship in my college. It's a mechanical internship. I'm a computer science student. I hardly remember when I applied for this, but I applied, and it's been a month since the mentor gave me a task to do, but I haven't done it. But today, that's exactly what we are doing. We will be going live and we'll be studying, figuring it out with you guys, and we'll be just doing it as much as we can. Do you understand what I'm saying? Let me explain in a better way. So how about I share my entire screen? You guys can know. I go to ChatGPT. Yeah, I'm hoping you guys see me now, right? Where is it? Yeah, you guys can see me. Yes. So the name of the internship is Digital Twin for Grinding. What do we mean by that? Let's understand the domain. Uh, so today we'll be making a version 1 in under 2 hours. The objective is to end this session with a working dashboard prototype and enough understanding to explain every component. First up, we need to understand the domain. We need to understand what directly affects the dashboard. What is grinding? Why is grinding used? Grinding speed, feed rate, depth of cut, grinding force, dynamometer, surface. You should be able to explain why these are your inputs and outputs. Huh. So basically, the title is Digital Twin for Grinding. So grinding is a mechanical process that happens in machines and all. Now we are making a digital twin for it. So we are making a twin that is similar thing but digitally. You can't grind things digitally, but we're making a digital twin for it. So that I think we make a prototype, we analyze all the processes, maybe we train AI to calculate speed and stuff, something like that. The first task would be to understanding the domain. Then we have to define the product. I'm sorry if there's a lot of noise in the background. It is what it is. Who is the user? What problem does this dashboard solve? What decision should it help make? What information must be always visible? What should trigger a warning? We need a one clear product vision. Then we need to design the dashboard, create a rough wireframe, header, annual input, वगैरह. Learn the tech. You only understand Streamlit basics, Panda basics, Plotly basics, Python and stuff. Build a dashboard, polish and think ahead. That stuff like that. So before we start, I'll put a quick link on my Instagram. I don't have followers, but let's see if someone wants to join the stream. They will join the stream. Currently, there are no users as expected, but yeah. All right. So let's put up a story, no? Yeah, let's put up a story. Give me a few seconds. It will take hardly some time. And then, until then, what can we do? Until then, let's play something. Let us do a stopwatch. You, Arey? Yeah, you just watch time passing by until then. Give me a second now. Uh, uh, uh. All right, I think that should be enough. Let's start without any further ado. Uh, let's just paste it again. Let's start with number one. All right. So, grinding. Grinding is a precision finish process in manufacturing. Instead of cutting material with a blade like milling or tuning, a rotating abrasive wheel removes tiny amounts of material. Think of it as an extremely fast, extremely precise sandpaper. Okay, that makes sense. Purpose to improve surface finish, achieve accurate dimensions, remove tiny imperfections, produce high quality parts. Examples: engine shafts, bearings. You guys can see me, right? Yeah. Okay. Let's have a look what grinding looks like. Mechanical. Oh, makes sense. Something like this. All right. So it's a precision finishing process. Instead of cutting material with a blade, we have a wheel. Makes sense. It improves surface finish, achieve accurate dimensions, remove tiny imperfections. Engine shafts, bearing gears, aerospace components, surgical tools. Now, why grinding? Imagine making a metal shaft. Turning gets it close to the required size. Grinding is the last step that makes it okay, perfectly smooth, perfectly round within tiny tolerances. Without grinding, rough surfaces, higher friction, more wear, lower precision. I'll just do one test whether I'm audible. No one's watching, but still. Yeah, I'm audible. I'm just not visible. Okay, let me fix the visible part. How do I fix the visible part again? कैमरा बनाता था यार सेंटर स्टेज करना पड़ेगा स्टूडियो लाइट रखनी पड़ेगी पोर्ट्रेट रखना पड़ेगा इसको थोड़ा सा ऐसे रखना पड़ेगा यार that should be enough. Yeah, I guess that should be enough, no? थोड़ा स्टाइल कर देते अजीब लग रहा हूँ पता नहीं क्यों. Yeah, whatever. All right. Yeah. So, why grinding? Imagine, ठीक है. Without grinding, we can't have a rough surface. We can't have a higher friction. There is more wear. There's lower. Now, what are the three inputs that we go through while grinding? These are called process parameters because the operator can control them. Grinding speed, how fast the grinding wheel rotates, that is RPM and meter per second, so rotation per minute. Think higher speed, more abrasive particles passing over the surface every second. If speed increases, now I have an app called Hey Clicky integrated into it. So if I press control option two times and ask it what is abrasive, it starts accessing my screen as well to get a context, and it will give me an answer pretty soon. But yeah, how fast the grinding wheel rotates. All right. If speed increases, advantages better finish, often faster material removal, cleaner cutting. Disadvantages more heat, wheel wear, risk of thermal damage. Abrasive means a hard, rough material that grinds or wears away a surface by rubbing against it, like the tiny hard particles. Think sandpaper, that's the every. Okay. Think sandpaper. Do you know sandpaper? समझो वही है abrasive particles, I guess. ओके स्पीड बढ़ेगी ज्यादा अच्छी फिनिश होगी डिसएडवांटेजेस है कि हीट ज्यादा होगा व्हील वेयर होगा रिस्क ऑफ थर्मल डैमेज डैशबोर्ड द ऑपरेटर चूजेस दिस वैल्यू कि कितनी स्पीड रखनी है नाउ फीड रेट हाउ फास्ट द वर्क piece moves relative to the grinding wheel units usually per minute तो wheel है and I think there is a workpiece so imagine painting a wall. Move slowly, smooth paint. Move quickly, brush marks. Exactly the same idea. Higher feed, advantages, faster production, rougher finish. Okay. What does workspace mean here? What does workpiece mean? It's thinking. Workpiece is the beam. Okay, so there's a wheel. Now there's something, a metal piece that's actually grinding the wheel, right? So that is the workpiece. Higher feed. Okay. Advantages, faster production. Yeah, makes sense. All right, makes sense. Makes sense. Okay, makes sense. What else? What else? Yeah, depth of cut. Definition: how much material is removed in one pass. Okay, makes sense. Small depth, better finish. Larger depth, more material removed. Makes sense. Grinding force. This is important output when the metal wheel pushes against the metal. The force is generated. Imagine rubbing sandpaper. Push lightly, easy. Push hard, more resistance. Grinding is exactly that. Uh, okay. High force means wheel is overrated, loaded, too much depth, too much feed, wheel becomes dull. Consequences, poor surface finish, chatter, burn marks. This is why ma'am wants force monitoring. Manometer, it is a force sensor. It sits in the experimental setup and measures the forces. It tells you the force is high. This becomes our dashboard rating. Now there's something called as surface roughness. I guess it should be lower because better finish. Entire relationship is basically operator. Choose the grinding speed. We choose the feed rate. Feed क्या था? वो work piece and depth of cut. Then the grinding process happens, and there is a force generated, which is measured by dynamometer, and then there is a dash displays force, and it decides, and we can continue, adjust parameters, or stop process, and it analyzes the roughness as well. So operator controls speed, feed, depth. Why force? Because it reflects what is actually happening during grinding. हो भी रहा है कि नहीं and surface roughness it's the quality outcome everyone cares about. Why isn't the force entered manually? Three variables are speed, feed depth, dynameter force. Why is high grinding force usually undesirable? Because wheel overload. A lower RA value is it is smooth. Why is the force not entered manually? वो तो करने के वक्त होगा, I guess. I don't know. इसको पूछते हैं. Force isn't entered manually because it's a measured output, not a chosen setting. It changes in real time during grinding. अरे किधर चला गया आंसर? ओके हाँ चलो समझ आ गया. स्टेप 2. ओके समझ आ गया क्यों है. बिकॉज हम लैब में वहाँ ग्राइंडिंग मशीन डाली, हमने स्पीड डाली. वो रीडिंग वीडिंग देख लेगा, बताएगा अगर फोर्स का कुछ मसला है और उसी अकॉर्डिंगली हमें समझा देगा. ठीक है. स्टेप 3. क्विक साइड नोट. All right. Digital twin head mirrors the physical grinding process. लाइव सेंसर डेटा आएगा इसको इसके बाद पाइथन डैशबोर्ड लाइव चार्ट्स केपीआईज अलर्ट्स फ्यूचर एमएल प्रेडिक्शंस ओके पेज टू डिटेल लेट्स what on earth is a KPI features what is it I don't know अरे किधर गया बिस्किट खाना चाहोगे सब KPI stands for bismillah all right, center is live force versus time chart. Right panel is process health, active alerts, operator notes. Bottom is mm, experiment summary and all. Deliverable before phase 3. Write a products requirement document. ऑब्जेक्टिव है बनाना टारगेट यूजर है जो काम कर रहा है प्रॉब्लम स्टेटमेंट होगी वही इनपुट होंगे वो मैट्रिक्स आउटपुट होंगे बताएगा मशीन सही से चल रही है कि नहीं की फीचर है फोर्स वगैरह फ्यूचर स्कोप है एमएल ऐड करना प्रिडिक्ट करेगा रफनेस इतना ही है ना यू मेक इट आई गॉट इट Hi, one guy in chat. Um, big fan. He's a top fan. Hashtag one. He asked a question. I think Messi is the best player, bro. Messi is always the best player. Spain versus France happening today. Yamal will humble Spain, and we have Argentina versus England. Messi will humble England, and then there will be Spain versus Argentina. Very fun. Barcelona versus Barcelona, but Argentina will win. Thank you. No, no, no. Don't leave. Please cancel. Yeah. आर्किटेक्चर आप देख सकते हैं हमारे पास ऑपरेटर है, हम इनपुट्स डालेंगे, ग्राइंडिंग मशीन आएगी, ग्राइंडिंग फोर्स आएगा, डायनोमीटर आएगा, पाइथन बैकएंड आएगा और अपना डैशबोर्ड आ जाएगा, फ्यूचर स्कोप आ जाएगा, एमएल डाल देंगे। नेक्स्ट फेज। ठीक है। पढ़ो खुद ही, मैं थक गया पढ़ते पढ़ते। Wow, that's nice. Hi. Wow, I can see myself now. What's up? What's up? Let me check how it looks. Oh, that's so cool. What's up? You can see me now in a circle now, but not here. That is very fun. Can we make it bigger though? We can, yeah. That is crazy. That is interesting. That's actually pretty cool. Let me check. This is all MacBook, by the way. Yeah, this sounds good. How about I go to camera and I would that work? What's up? Or is it having a problem showing myself? This looks cool. I'll continue in this one. So, what is the डैशबोर्ड आर्किटेक्चर? हमारे पास ये होगा, हेडर होगा, एक्सपेरिमेंट कॉन्फ़िगरेशन होगी, लाइव मॉनिटरिंग होगी, एक फोर्स चार्ट होगा, स्टेटस आएगा, एक्सपेरिमेंट लॉग आएगा। इसमें प्रोजेक्ट का नाम होगा, इसमें कॉन्फ़िगरेशन होगी, ग्राइंडिंग स्पीड, डेप्थ ऑफ कट, ये हार्ट है, ये दिखाएगा फोर्स वर्सेस टाइम, एक ग्राफ, एक राइट पैनल में इंपॉर्टेंट नंबर्स आएंगे, एक्सपेरिमेंट की ड्यूरेशन, केपीआईज, करंट फोर्स, एवरेज फोर्स, बॉटम में आएगी सेकेंडरी इंफॉर्मेशन, ऑपरेटर नोट्स, ऑपरेटर को कुछ लिखना है, भाई ये मशीन अच्छी है, ऐसा कुछ डेटा फ्लो है, और ऑपरेटर वगैरह सब कुछ, और generate receive calculate average maximum status variables think before coding speed है feed है depth है force है time है calculated average force max force future predicted component tree आएगा अपना sidebar inputs controls KPI cards force chart status panel nodes prediction panel Build order, step 1 page layout, step 2 sidebar, step 3 KPI, step 4 folder structure, digital twin, app, assets, data, utility, components, requirement, readme. Tech stack हमारा Streamlit, Panda, Plotly, NumPy, scikit-learn. All right. Before going to phase 4, how about we do a quick crash course on the tech stack. This is the tech stack. अरे अरे रुक जा मेरी जान. हाँ, तो टेक स्टैक है हमारा रियल वर्ल्ड सेंसर डेटा. पांडा एक लाइब्रेरी है, आई गेस, दैट क्लीन्स एंड प्रोसेसेस. numpy is a library that generates and calculates. Plotly is a visualization. Streamlit is a dashboardization, and scikit-learn is later. Streamlit is front end. It's React for Python, but 100x simpler. You write st.title, digital twin, dashboard, boom, title appears. You need a textbook, st.text input. You need a button, st.button. You need a chart, st.plot, plotly chart figure. You need a metric card, st.metric. Everything is Python. Your Python code, Streamlit, beautiful web dashboard. Pandas, everything becomes a table and Excel basically. This is called a data frame, DF. Excel sheet, not database, just data. तो इसमें हम अपना डेटा कैलकुलेट स्टोर करेंगे. प्लॉटली में चार्ट बनाएंगे. ये बना देगा चार्ट. पांडा स्टोर करेगा डेटा. वो करेगा numpy है मैथ. You will mostly use for generate sample force, generate fake values until lab gives real sensor reading. NumPy is a calculator. Scikit-learn is what is Scikit-learn? ये है, इससे बस लर्निंग होती है. ये फंक्शंस हम इस्तेमाल करने वाले हैं. ये डेटा फ्रेम हम इस्तेमाल करने वाले हैं. ये प्लॉटली हम करने वाले हैं. ये numpy हम करने वाले हैं. ओके, नेक्स्ट स्टेप, नेक्स्ट फेज. लेट्स गो. अब क्या तू चाहता है मैं खुद कोडिंग करूं? वो तो आती ही नहीं है मुझे करने. अब क्या करें? प्रॉम्प्ट दे दे, एजेंट में डाल दूंगा. फिर सीखेंगे. और चलो गाइस, वक्त आ चुका है कोडिंग करने का. क्या आप देखना चाहते हो मैं कोडिंग कैसे करता हूँ? आज हम देखेंगे कि मैं कोडिंग कैसे करता हूँ. पहले आप ये देखोगे कितना कूल लग रहा है. वाओ, रिएक्शंस भी है ना हमारे पास. वाओ. You're a senior software engineer. I'm a computer science student building my first industrial dashboard for a mechanical engineering internship. Oh my God, let's go. Figuring, figuring it out, figuring it out, figuring it out. Let's see, let's see, let's see. Okay, okay. Let's see what's gonna happen next. Okay, okay. Yeah, yeah, yeah. All right. What next? You are a senior software engineer and mentor. I'm a computer science student. Um, let's ask Vicky. I'm doing this and live streaming it as well. How about you give me a YouTube description? Great SEO, but cool. So more people join. She's working at the pyramids tonight. Yeah, yeah, yeah. It's in my clipboard. Oh my God. Apparently, I can't paste the description. So where do I store it? I'll store it here. Notepad. There you go. All right, guys. Let me open my anti-gravity and we'll work on. All right, guys. We are back. How about I share my entire screen and we are live and I pasted the prompt. Here's the project directory. Here's the state management. There's the simulation and live updating. Here's a doc theme. Here is a user review required. Okay. Build steps. Grinding for simulator, automated verification. Makes sense. Proceed. Proceed, I guess, bro. Just built it. Oh, it doesn't move ahead unless it explains. Chalo, what we have built and why. Directories. How about I open an IDE as well? We open a folder. Just made a folder today, if you don't know. दो सेकंड रुक जाओ दोस्तों. I'm trying to figure a few things out. Very good. Can't find it. It's as if it's not here. Is the folder made, sir? Because I can't see the folder. Trying to figure a few things out, guys. Okay. I still can't find the folder. I can't find the folder. Recent. What's wrong? New folder. Digital twin, I guess. Open. No, it's not what I want. Can you do the school feature? You can't. All right. ये prompt दिया हमने इसको, इसने मुझे ये जवाब दिया कि इसने क्या बनाया है. इसने directories बनाई है, data, components, assets. We structured the project to separate data simulations, the mimics production. Then we have requirements.txt. We added core libraries, assets, Although it would be nice if I can see the code. Like, where is the code? How about I see? कुछ कुछ तो कर रहा है दोस्तों। कुछ कुछ ये करते रहते हैं। टास्क लिस्ट उसने बना दिए। क्रिएट प्रोजेक्ट डायरेक्टरी कर दिया इसने। ये एक ग्राइंडिंग फोर्स सिमुलेटर बना रहा है। अब फिर ये बनाएगा, ये बनाएगा, ये बनाएगा, ये। सही है मेरी जान, बनाओ जो बनाना है। मैं रोकूंगा नहीं। आप बनाओ। तब तक ये देखते हैं। readme panda readme file is this. We create a virtual environment, we install the dependencies। अच्छा, वो रिक्वायरमेंट में लिखा था क्या क्या चाहिए, कौन सा वर्जन चाहिए हमें। एंड हमने रन कर दिया ऐप को। फिर एसेट्स में हमने स्काडा इंस्पायर्ड इंडस्ट्रियल डिजाइन सिस्टम बना दिया। उसमें हमने एक एपीआई कार्ड बनाया है। बैकग्राउंड कलर है, बॉर्डर रेडियस है, बॉक्स शैडो है, ट्रांजिशन है। फिर कार्ड टाइटल है हमारे पास। फिर मोनोस्पेस डिजिटल लुक है। फिर स्टेटस कलर्स है, पल्स एनिमेशन है, कस्टम लेआउट है, सेफ टेक्स्ट और वार्निंग टेक्स्ट और क्रिटिकल टेक्स्ट के लिए एक एक कलर रख दिया है। यहाँ पे इनिशियलाइजेशन है, यहाँ पे कंपोनेंट्स है। सही है भाई, कुछ कुछ तो कर रहा है। अभी ये इंस्टॉल कर रहा है सारी चीजें जो भी इसको इंस्टॉल की जरूरत है, इसको हम करने देंगे। इंस्टॉल कोई मसला नहीं है, हो गया। सारी चीजें इंस्टॉल हो गई। Now we will run our simulator verification script using the newly created virtual environment. I guess bro, virtual environment बना दिया आपने। सही है भाई, चिल करो, बनाते जाओ आप। आपको रोका हमने, आप बनाओ, अब चिल करो भाई। कुछ बना दिया इसने, कुछ तो बना दिया। Alright, I ran our verification script under the virtual environment. It successfully loaded data simulator and outputted single data point calculation, initial data set, data frame, time 0, force t. They contain physical grinding force values combined with realistic vibration and rotational runout cycles. ये बनाया आपने, डेटा सिमुलेटर बनाया। जरा दिखाओ कहाँ है। कहाँ है भाई, दिखाओगे? ये दिखा ही नहीं रहा है। ये नहीं दिखाएगा, छोड़। अब बनाना है component side पर। Let's understand the architectural details of state management in Streamlit. The challenge: every time a user changes a slider, inputs text, or clicks a button in Streamlit, the entire script runs again from top to bottom. If you click a start button, it returns true during that run, but returns false on the next run. The solution: we will use Streamlit's st.sessionState. It acts as a persistent memory key value across reruns. We will drag whether it is running a Boolean flag, checking that the experimental simulation is active. A pandas data frame storing the active runs, elapsed time steps, and post readings, and a session elapsed counter for a simulator. Sidebar component structure. We will place all sidebar sliders selection box under the components.sidebar. The function render underscore sidebar will render the inputs and return a directory of the selected grinding parameters plus trigger state changes when buttons are pressed. क्या 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 रेंडर साइड बार ओके चलो सही है what else so this is um component sidebar yeah uh we have imported Streamlit, we have imported datetime, data.simulator from grinding simulator, different defined render sidebar, renders the parameter panel in the left sidebar and manages the simulation start triggers, returns the user configuration parameters, initialize session states if they do not exist. If is running not in session state, false. If experiment not in session state, none. Current time, state, experiment configuration, identification input, count, ID, unique identifier, workpiece, material. चलो कुछ बन गया है। फिर डेटा में क्या है? पाई कैश। कुछ तो है ये। अच्छा, मिनट। ठीक है, रीड में। चलो नाइस है। ओके, कंफर्म चेकलिस्ट क्या थी हमारी? अभी तीन और स्टेप। कंफर्म। तब तक जब तक ये बनाएगा तब तक इसको बोलेंगे मुझे समझाओ। करंटली गोइंग ऑन from you explain all this so like I understand and that's and stuff like I think okay. Not this bro, not this. Okay, chill out. ऑलराइट, पहले है हमने इंपोर्ट की numpy लाइब्रेरी। और किया हमने ओके, ये एक कंस्ट्रक्टर है। We don't call it self dot workspace. It's the coefficient self. Dictionary is e value. We multiply by a coefficient. I guess. Okay, makes sense. This is just a function. This should be a decimal number. Get steal, we will get this. Doesn't know yet. Never changes. I guess. Higher feed, higher force, higher depth, higher force, higher speed, slightly lower force. Power. ओके, साइन वेव बनाने के लिए साइन एनपी डॉट साइन रियल डेटा नॉट डेटा पाई चार्ट रन आउट वेव मोशन खुद ही बना देता है सेंसर डेटा मीन स्टैंडर्ड डिविएशन मैक्सिमम डेटा सेट एम्प्टी लिस्ट फॉर लूप ओके 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 ऐसे भाई समझ गया तेरा भाई समझ गया मजा आ रहा है आज पहली बार वाइब कोडिंग के साथ समझ भी रहा हूँ अच्छा जी कुछ नया आया क्या फिर इसके बाद अब बनाते हैं टॉप केपीआई कार्ड्स एंड स्टेटस लॉजिक dynamic metric aggregations inside components.kpis.py we calculated average current peak force from the rolling data stream. Siemens SCADA style indicator card replaced basic metrics with clean left bordered custom panels. We built a flashing alarm notification. Makes sense. Uh, components के अंदर इसने ये सब किया. Okay. देखते हैं components के अंदर क्या किया. साइड बार में क्या है? नॉट हाई केपीवाई का केपीवाई का तो कार्ड ही नहीं है. अच्छा जी करंट फोर्स डायनामिक ओके इसको बोलते हैं समझो This is the MacBook is kind of hot now. It's heating up. Take the force data, calculate four numbers, display four cards. Overall flow data frame force data. Calculate key prominent features. It's been 1 hour since we have been streaming. Let's go. Determine status, display, show warning. Imports, import as ST. Okay, it's been 1 hour. We can take a break. We should take a break now. I think we should take a break. But if I take a break, I might not come back. Let's see live. Is anyone watching us? Why is no one not watching me, yaar? Please, someone watch me. It's very cool. I'm teaching you. Imagine Speed doing a live stream where he's learning AI. Why do people watch gaming streams? You can game yourself. I feel like है scope है coding streams का, but it's just not clear yet. Maybe. Who knows? Who knows? Who knows? इसकी एक फोटो उठा लेते टाइम भी आ जाए तो सही है. ओके ओके हाई लिख देते हैं हाई लिख देते हैं हाई लिख देते हैं चैट में. अच्छा जी तो we import Streamlit as st. St is everything related to UI. Function is render KPI cards. Data function called render KPI cards that receives a panda data frame. Type hint is pt.data frame doesn't affect execution. It just tells pass me as a data frame. तो df का मतलब से pt.data frame है. इसे कहते हैं type hint. ये हमने डिक्शनरी इंपोर्ट की है. इसे कहते हैं doc string. इसे कहते हैं edge case. If def is none or def.mp तो no data exists, right? अगर अभी कुछ हुआ ही नहीं है. Without this, force would crash. So we first ask, does data exist? If no, we use default values. Current force is zero. Instead of crashing, it will just show 0 Newton. What else? Values. ठीक है. Status is off. Machine hasn't started. Not an error. Just waiting. ठीक है. Else is data exists. Okay. Current force. Probably the most important line. Gets the force column. Step 2 ilog get by position not by variable. Python shortcut last item 10 20 30 negative indexing ilog -1 some shit it means average max threshold logic while these three variables okay columns st dot columns just write st dot columns for column 1 column 2 markdown st dot markdown you are saying put this inside column 1. Notice this means string formatting. Example force is equal to 1 to 3 without F. Force shows force with F shows plain text. Alright, makes sense. वापस पढ़ते हैं. Formatting. String formatting कहते हैं इसे. HTML को बुला दिया भाई हमने. एक KPI कार्ड को बुला दिया. ये हमने एक डेसिमल प्लेस बना दी. Streamlit blocks HTML. This is I know what I'm doing. Unsafe allow HTML to same card repeated. Status card. Final alert. Why F again? Data frame extract metrics current average maximum threshold rules. This function does two jobs. Business logic UI rendering. A cleaner design is current version is perfectly fine. I don't care bro, it's probably good. This we have built this. Now we need to make charts. Uh, while Streamlit has built-in charts, they lack custom configuration threshold markers, so we do Plotly. Then we have SCADA visualization best practices, a calendar palette, a threshold plotting thousands of. We will implement a rolling filter displacing only the late. Makes sense. Let's confirm. Warning आई थी ना कुछ कहीं तो warning आई. Who cares? Alright. हमने बना दिया एक डेडिकेटेड विजुअलाइजेशन कंपोनेंट जिसमें परफॉर्मेंस गार्ड था स्लाइस द डेटा अंडर परफॉर्मेंसेशन अलाइन चार्ट बैकग्राउंड. अब नेक्स्ट स्टेप है हमारा. इसको क्या हमें करना है पहले हम देखेंगे हमने क्या बनाया. हमने चार्ट बनाए. रेफरेंस फोर्स चार्ट एज केस. नाइस है भाई नाइस है नाइस है. नेक्स्ट टीच My bad. लैपटॉप इस लो की गर्म हो चुका है। थोड़ा थक गया इंस्टाग्राम चलाते। मेरी स्ट्रीम कोई देख रहा है? 1 hour डन। 1 hour। कोई मेरी स्ट्रीम नहीं देख रहा है। पहले देखते हैं हमारी स्ट्रीम चल रही है कि नहीं। चल रही है हमारी स्ट्रीम, चल रही है दोस्तों। सही है भाई। Alright, the job of the file is to make a beautiful graph. Big picture, data from last 100 points. Plotly figure adds force line, adds threshold line, style chart, display in Streamlit. Okay. Import as go. People shorten it to go just like Python. ठीक है, ग्राफ को हम go की तरह import करते हैं। फंक्शन है हमारा रेंडर फोर्स चार्ट। टाइम और फोर्स मिलता है, दो वेरिएबल्स मिलते हैं। याद है बचपन में अगर ग्राफ्स नहीं पढ़े होते तो ये समझ नहीं आता। मैथ्स इज सो इम्पोर्टेंट। एज केस एग्जैक्टली लाइक बिफोर कि आ, अगर कुछ नहीं है तो क्या होगा। अपडेट डॉट लेआउट इज एवरीथिंग एक्सेप्ट द डेटा। थिंक css बैकग्राउंड हाइट एक्सेस ऑल इनसाइड अपडेट लेआउट। ठीक है। annotation put text inside the graph return मीन स्टॉप है, डोंट एग्जीक्यूट रिमूविंग। रोलिंग विंडो हम 100 पॉइंट्स को ही करेंगे। इसको हमने बना दिया ये। एड ट्रेस। ट्रेस क्या होता है? एग्जाम्पल 1। थिंक चार्ट एड वन थिंग, दैट थिंग इज कॉल्ड ट्रेस। फोर्स आई गेस means something. Despite the name, it can draw lines, point plus points. Access time, voice, force. Mode is lines. Line is dictation. Color, width, प्लॉटली का hover फीचर है। या add hline amazing function instead of drawing threshold yourself just means draw horizontal line. There's a warning, there's a critical, there's a dashed, there's an annotation text, there is update layout, there is title. I guess x-axis grid color 09. Dynamic range, imagine normally force suddenly instead of cutting off they say largest force plus 30. Always leave headroom, looks nicer. सही है भाई। सही है भाई। सही है भाई। सही है भाई। वार्निंग लाइन, क्रिटिकल लाइन, स्टाइलिंग। क्रिएट्स डेटा, समराइज डेटा, विजुअलाइज डेटा। सही है मेरी जान। मूविंग ऑन। अब हमें ये करना है। ये करना है। ये करना है। स्ट्रीम ब्लॉक append this row. ओके। ओके। कुछ तो बोल रहा है भाई। कंफर्म। कन्फर्म। सही है भाई, सही है, सही है। If you are watching, say hi in the chat. If you're not watching, say hi in the comment. Will we ever make it big? I don't know. Until then, we keep trying. ये वैसे भी पढ़ना ही था, मुझे लाइव स्ट्रीमिंग कूल लगता है तो मैंने लाइव स्ट्रीमिंग कर ली। एक दिन मैं इतना इंटरेस्टेड होऊंगा कि लोग मुझे पढ़ते हुए देखेंगे, बहुत सारे, हजारों, लाखों। Who knows? Who knows, bro? Anything can happen. If like people can watch Kai Cenat, उसको बात नहीं आती है करनी। ये I think we should do this. I think we should do this. वैसे बात करते हैं तो maybe it's entertaining. I think that's the point. But if you want, I can start screaming like speed. Let's go. Okay. अच्छा जी बना दिया इसने, कुछ तो बना दिया, क्रेजी बना दिया। We have done everything. प्रोजेक्ट सेटअप कर दिया, कस्टम स्टाइलिंग कर दी, फिजिक्स कर दिया, यूआई कंपोनेंट कर दिया, सिस्टम इंटीग्रेशन कर दी। कुछ तो क्रेजी बना दिया दोस्तों। अब देखते हैं कि हमने यहाँ पे क्या बनाया। ऐप डॉट पी वाई में क्या बनाया हमने। She's working as a pyramids tonight. ऐप डॉट पी वाई में हमने बना दिया, इंपोर्ट कर दिया, मेन पेज सेटिंग कर दी, ये सब कर दिया। ये बोलते इसको हमने क्या किया। इसके बाद है लॉन्च कर देने का। Hi guys, we are making a digital twin for grinding. Grinding is a mechanical process. हम उसको पाइथन से सिमुलेट कर रहे हैं कंप्यूटर में। तो उसका ये एक कोड है, app डॉट पी वाई। दिस इज द मेन फाइल। थिंक ऑफ इट एज a constructor for process. Um, we have set up Streamlit, load CSS, create simulator, build header, build sidebar, show KPI card, show chart, show notes, show statistics, show AI panel, run live simulation. ये मुझे इतना अच्छे से समझना है कि मुझे लिंक्डइन पे भी एक वीडियो बनाना है थोड़ा प्रोफेशनल, फिर इंस्टाग्राम में भी बनाना है थोड़ा फनी, और ये समझाना है और लोगों को बोलना है मेरा प्रोजेक्ट देखो। और इसमें कोई बिजनेस लॉजिक क्यों होगा इसमें। इंपोर्ट टाइम है, इंपोर्ट ओएस है, कस्टम इंपोर्ट है जो हमने खुद बनाया, ग्राइंडिंग सिमुलेटर सेपरेट किया था हमने पहले ही कोड, फिर पेज कॉन्फ़िगरेशन बना दी, पेज टाइटल वाई बड़ा लेआउट वाइड बना दिया। दिस पार्ट कंफ्यूजेस बिगिनर्स, वेयर इज स्टाइल डॉट एसएस, इट फाइंड्स इट, ओके, instead of gets folder instead of file. um Makes sense, cool. जॉइन देता है, सही है भाई। एग्जिस्ट है तो उसको बुला दो। विद की वजह से रीड होती है, बिकॉज पाइथन ऑटो है। With open read file. Why with instead of open? Because Python automatically closed it, I guess. Read st dot markdown css को मैं पेज में बना दिया। ठीक है। Decorator modify functions. Okay. Without cache, every refresh is a new simulator. We lose state. With cache, we first time create simulator, store it, reuse forever. Now we get simulator. Instead of this, they wrapped it because cached simulator get simulator. Now entire app uses same simulator. Header is literally HTML. Nothing special. I don't even know HTML. Sidebar config render sidebar ask sidebar return all user inputs. Okay. Biggest Streamlit concept is session state is a memory. Every Streamlit refresh, everything resets. Session state says remember these values. ठीक है state कैश है समझ ले रहे हैं हमें. If experiment data is not in session state मतलब पहला launch है मतलब created. KPI is cards. Chart is chart. Column is column. What else? All right, it's time to test it. Let's open terminal and let's open this. Let's see if it opens. Okay, let's go. Current, there is Everything is normal. We set up the grinding speed as 34, feed rate as 1000, and depth of cut as itna. Experiment ID, we make it 001. I want titanium alloy. I want aluminum oxide. And we say deploy. What do we say? How do we start? We start run, and the running happens. And there's a critical overload. Machine is happening, high vibration. We tell it to stop the run. And then it shows me a chart. Something happened. Plot takes a screenshot apparently. And we can see that screenshot. Sounds good. Let's keep it very low. Something is happening. Yeah, okay. Let's start run. This is the latest one. It is safe. Current normal force is this. And it keeps on happening, I guess. Peak grinding force, mean grinding force. We have all this. We can stop the run. This was all there was. We'll train a sky sit. Okay, ये भी कर लेंगे कभी. मैम को भेज देते हैं. एक स्क्रीनशॉट उठा देते हैं. Why can't I take a screenshot? Okay, made a screenshot. Alright, guys, that was it. It happened. Something happened pretty nice. I think next step would be to implement SkySet वगैरह, but अभी वो करने की हिम्मत नहीं है. This was our platform. I'll show you it again if you want. Grinding machine twin console. Current force दिखा रहा है, grinding force दिखा रहा है, safe critical वगैरह दिखा रहा है. Threshold force calculate करता है through speed, feed rate, depth of cut. ये सब दिखाता है. यहाँ पे हमारे ऑपरेटर नोड से हाई. मैं थक गया. कमांड प्लस एंटर. पता नहीं क्या मतलब है इसका. कुछ तो होता होगा. ये है ये है रुक जाओ. um, Alright, guys, that's pretty much it. This is our console, and thank you so much for joining. Next time, maybe we will implement machine learning. Bye bye. Thank you. Let's end the stream.